space, stars, planets. This is what fascinates us and scares us at the same time. In the past, we could not even imagine what mysteries and dangers the universe would present to us. Today, we'll reveal some of them. In this video, you will learn about stars vanishing forever without a trace. Unbelievable, huh? Well, not really. So far, several hundreds of cases have been identified. What can it be, one might wonder? Perhaps an invisible force devouring the stars? A glitch in the Matrix? Could someone else be involved? We'll also reveal the secret of unusual cosmic signals coming from a single source. A total of 1,652 powerful radio signals were detected by the observatory in a 47-day period from August 29th to October 19th, 2019. So what was it? Radio communications of highly developed civilizations? I will also tell you what scientists think about hypothetical extraterrestrial life forms, the level our civilization has reached on a universal scale, the time needed to reach the next stage, and finally, you'll get to know what civilization owns the whole galaxy. Our red planet neighbor also hosts a lot of surprises. In 2018, a huge cloud appearing every day was discovered. It began with the extinct Arzia Mons volcano and stretched from east to west like a dense white plume. And that's far from all the mysteries of our solar system. Our next stop is asteroids that might be dangerous to Earth. And finally, we'll talk about what would happen to the universe in 20 billion years. And when will the last star go out? On April 12, 1950, the Palomar Observatory in California took a picture of a group of stars during its regular starry sky observation. Half an hour later, a snapshot of the same area was taken. 9 stars from that group have gone missing. The stars disappeared and have never reappeared since. Never. Because this strange phenomenon wasn't given much attention back then, it virtually went unnoticed. Only 70 years later, Dr. Beatrice Villarroel from the Nordic Institute for Theoretical Physics, Nordita, made a public announcement that something was wrong there. Something really strange was going on. A group of scientists led by Beatrice Villarroel has been working since 2017 on the vanishing and disappearing sources during a century of observations FASCO project. As the team's research suggests, it's not only in 1950 that stars have gone missing. To finally resolve the 9 missing stars conundrum, the team used the largest optical telescope in the world, the 10.4-meter Gran Telescopio Canarias in the Canary Islands, to look deeper into the same region of the sky. Still, there was no trace to be found. The most obvious explanation that came to mind was the poor quality of photographic plates and other shooting defects. But further in-depth research showed that it's not that obvious and can't be explained away so easily. The group sampled 10 million stars from the UNSO, the United States Naval Observatory catalog. They compared the sample to the data from the Sloan Digital Sky Survey. The team also compared the objects with data from the European Space Agency's Gaia Orbiting Telescope, which is currently collecting accurate data for more than 1 billion stars in the Milky Way. Initially, scientists identified about 290,000 objects that have presumably gone missing. Upon careful examination, only one potential missing star remained, and even that one raised some doubt. This was followed by a new, more comprehensive study. Scientists took a much larger sample of 600 million objects, having up to 21st visual magnitude from the USNO catalog. For reference, the higher the magnitude, the fainter the object is. This time, numerous images were compared with the data from the Pan-STARRS system. It's a robotized system of panoramic view and rapid response telescopes. It contained objects up to the 23rd visual magnitude. This means the new sample took into account dimmer objects, and the sample itself was 60 times larger. Originally, 150,000 objects were thought to be missing. All of them have been thoroughly analyzed. Scientists were able to sift through them and ended up with about 100 objects whose disappearance was scientifically unexplainable. What makes it really strange is that when a star dies, it doesn't just disappear without a trace. And this certainly doesn't happen out of the blue. If it's a massive star, it explodes into a supernova, leaving behind either a neutron star or a black hole and a bunch of dust. A less massive star would leave a white dwarf and a planetary nebula behind. So what really happened to missing stars? Currently, there are several hypotheses. One of the most obvious explanations for this phenomenon is at the same time the most boring one. Some stars significantly change their luminosity over time. For example, a star's powerful flash made it into some old photos. But then the star's luminosity dropped by several magnitudes. Remember, the USNO catalog lists objects up to the 21st magnitude, and Pan-STARRS up to the 23rd visual magnitude. What if the luminosity of a star has dropped below the visibility threshold of modern tools? Then it hasn't disappeared. It simply cannot be seen. But some dreamers who won't accept such simple explanations are in luck. This hypothesis doesn't provide clear answers, and in some ways doesn't hold water. It has been suggested that missing stars were moving faster than expected, and they might have simply flown away in an unknown direction in the short window of time when the shots were taken. This hypothesis doesn't bring much clarity either. And not every object's disappearance can be explained this way. At first, this hypothesis seemed to be the most plausible, especially since astronomers had already seen such a phenomenon. Scientists believed that all massive stars explode as supernova at the end of their lives. However, according to theoretical estimates, from 10 to 30% of stars that turn into black holes collapse without a supernova explosion at the end of their lives. The explosion is not powerful enough for the stellar matter to overcome the gravity of the newly formed black hole. Scientists believe this is what happens to stars weighing 20 to 25 solar masses. So far, there are only 2 known stars that presumably collapsed this way. N6946-BH1 is an extinct star in the NGC 6946 galaxy, lying approximately 22 million light-years from the Sun. It was a red giant weighing 25 solar masses that was thousands of times more luminous. In March 2009, N6946-BH1 slightly increased its brightness, but in October of that year, it vanished from the optical range, although it remained visible in the infrared spectrum. Eventually, the object vanished completely by October 2015. It would seem this is as simple as this, but statistics refutes this scientific explanation. Failed supernovae are extremely rare. Modern scientists claim it occurs on an average once every 3 centuries in our galaxy. This does not fit in any way with 100 stars that have gone missing in just 70 years. The VASCO project is implemented in close cooperation with the SETI project. Therefore, it is not surprising that Dr. Villarroel's team didn't discard such an exotic hypothesis. Indeed, one part of the research report mentions that the phenomenon can be explained using a more exotic extraterrestrial civilization hypothesis. Once again, scientists cautiously assumed the artificial nature of the astrophysical phenomena. This wasn't based on solid facts, but rather the absence of such to disprove that missing stars can in fact be taken over by highly advanced intelligent civilizations. A similar theory posits the construction of gigantic astro-engineering structures around the stars used to maximize stellar energy consumption. There was coined a special term for this, the Dyson sphere. In one of the previous episodes, we talked about Tabby's star and its strange luminosity fluctuations. The most daring theories boiled down to the existence of such structures around the star. The Dyson sphere isn't the only theory explaining the strange disappearance of observable objects that is too out there. Unbounded by rational frameworks, futurologists suggest much more daring things like galactic superpower laser beacons, the glow of gigantic spaceships' engines carrying whole civilizations on board, or even stellar engineering of highly developed civilizations capable of extinguishing the stars that interfere with them for some reason. As incredible as all this may sound, paragraph 5.3.1 of the scientific report by Beatrice Villarroel's group was humorously titled, "Giving Extraterrestrials a Second Chance." The search continues, but no matter how much effort it takes along the way, the amazing discoveries are undoubtedly worth it. According to scientific theory, space objects should be classified as dangerous asteroids in case their orbit lies extremely close to the Earth and the diameter exceeds 140 meters. Even such seemingly small dimensions would mean a lot of destruction and natural disasters in the event of a collision. Fortunately, the risk of witnessing such a collision is almost reduced to zero for modern human civilization. On average, asteroids cause some real damage to Earth once every 10,000 years, according to statistical research. This space object stole the spotlight and has been considered controversial for more than a year. The Apophis asteroid was discovered in 2004 at the Kitt Peak Observatory. According to current information from NASA, the diameter of Apophis ranges from 310 to 340 meters. This data is considered the most accurate as it was obtained by the Herschel Space Telescope. Despite the spread of information about the immediate danger the asteroid poses to Earth in 2029 and 2036, NASA representatives flat out refuse such risk. Experts were able to come to this conclusion after the research conducted in 2013. Then, the asteroid orbited at a distance of almost 14.5 million kilometers from the Earth. Until that time, the risk of a collision in 2029 was estimated at about 3%. Moreover, scientists were confident that the orbit of Apophis could change after getting closer to the Earth. This would consequently increase the risk of a collision as early as 2036. However, as of 2021, most scientists agree that the risk can be estimated as 1 in a million. However, why not hypothesize for a second that such a collision occurs? What would happen to humanity and the planet? Initially, NASA representatives stated that the fall of the Apophis asteroid would lead to destruction equivalent to 1,480 megatons of trinitotolene. Subsequently, this value decreased to 506 megatons after experts accurately determined the size of the space object. Naturally, it's rather difficult to predict the hypothetical result of a direct collision of the asteroid with the Earth. Indeed, there are many variables. The potential consequences depend not only on the place, but also on the impact angle. One thing remains certain. Apophis wouldn't be big enough to cause the impact winter, but the destructive effect would spread over many thousands of kilometers. What is an impact winter, you might wonder? The fall of the asteroid would make a huge volume of soot and carbon gas stay in the atmosphere. This cloud would shield the planet from the regular dose of solar rays, which would in turn trigger climate change. It would become dark, causing the oxygen levels to decrease. Plants wouldn't be able to actively perform photosynthesis, and living things would find themselves in the glacier period. The analysis shows that a fall of a 5-kilometer asteroid or comet in a small body of water would be enough to throw a significant amount of matter into the atmosphere and decrease the planet's global temperature. It's for this reason that people are afraid of an impact winter more than a simple collision. There's no doubt, no one wants to go down like dinosaurs. Naturally, the fall of an Apophis near populated areas would lead to an earthquake. For example, an earthquake with a magnitude of 6.5 would occur in a city within the radius of 10 kilometers from the impact site. If the asteroid fell into the ocean or even a large lake, then devastating tsunamis would destroy settlements for up to 300 kilometers around. There is virtually no doubt that NASA is telling the truth about the minimum danger the asteroid poses to the Earth in the next few decades. Despite this, scientists offer various options on countering a potential collision with Apophis. For example, a highly reflective film was considered. Its use would result in altering the asteroid's orbit due to the sunlight's pressure. Toutatis is another potentially dangerous asteroid for the Earth. Its story is no less intriguing than that of Apophis, at least because it starts on February 10, 1934, when it was first discovered. Then it vanished out of sight. Christian Paulus rediscovered it only 55 years later, on January 4, 1989. According to information by the IRAS observatory, the asteroid is 5.4 kilometers in diameter. The asteroid's movement is truly unique. If a person had a chance to visit this asteroid, it would seem to them that the sun rises and sets down in random places, and even more so at a random time. It seems like a perfect home for the Little Prince from the eponymic novella by French writer Antoine de Saint-Exupéry. As you might remember, seeing the sunset was one of this character's greatest sources of happiness. Unlike most other dangerous asteroids, Toutatis has a rotation period of 4 years. Therefore, it is often located quite close to the Earth. The closest Toutatis came to our planet was on September 29, 2004. That day, the asteroid was only 0.104 astronomical units from the planet's surface. This event enabled scientists to study its features in more detail and come to the conclusion that the threat of a collision in the nearest future is extremely low. Moreover, some scientists argue that in the next century, Toutatis may leave the solar system due to gravitational interaction with the planets. The irregular shape of the asteroid is quite noteworthy because it consists of 2 lobes with diameters of 2.4 and 4.6 kilometers. Most probably, the Toutatis' shape suggests that it was formed from 2 separate cosmic bodies. Another asteroid from our list hasn't yet received an official name, and the combination 53319 1999 JM8 is used to designate it. This asteroid was first discovered by the Linear Laboratory on May 13, 1999. With a diameter of 7 kilometers and a complete intersection of the Earth's orbit, it can be classified as a potentially dangerous object. According to NASA calculations, the closest distance between the asteroid and the Earth was observed in 1990. Then it approached the Earth at a distance of just 5 million kilometers. Despite this frightening figure, scientists guarantee that such problems won't arise in the 21st century, since the specific space object won't come closer than 38.3 million kilometers. Consequently, as long as potential risks from this asteroid are concerned, this century is going to be rather safe. The Goldstone and Arecibo observatories provided not only the approximate diameter of the described asteroid, but also several radar images. If you look closely, you can find that this space object resembles a chicken. Another asteroid that claims our attention is Didymos asteroid. It was first discovered thanks to the Spacewatch program at the University of Arizona. The asteroid was discovered on April 11, 1996. It was first named 1996 GT. It's worth noting that unlike most asteroids, Didymos has a satellite with a diameter of only 150 meters. The diameter of Didymos is only 0.8 kilometers, but it stands out for a completely different reason. It was Didymos that was chosen as the collision target as a part of the DART program. Globally speaking, this is the first project in the history of mankind whose main goal is to change the trajectory of asteroids and other space bodies using a spacecraft. This device and the project itself was developed in the Johns Hopkins Laboratory as well as at NASA centers. The official launch of the device took place on November 24, 2021, with a SpaceX Falcon 9 being used as a launch vehicle. The collision of the device and the Didymos asteroid, as scheduled by the DART program, should occur in October 2022. Depending on the result of this mission, scientists will be able to analyze the effectiveness of defense against planetary impacts. Naturally, you should take into account that the asteroids presented in today's episode aren't the only space bodies that are potentially dangerous to our planet. NASA continues to discover new asteroids that not only orbit the Earth, but also have a frightening diameter that would cause irreversible damage in the event of a collision. Hopefully, new, effective ways of countering the impending danger will be found by scientists in the near future as they take this matter quite seriously. As long as we travel in time in increments of centuries, we won't be able to see any major changes. But as our time jumps increase, the changes will become more dramatic. So we'll stop in different periods when something significant happens. 1,000 years. A huge period in terms of human life, and only a moment in the life of a universe. Even in our solar system, nothing dramatic will have happened yet. The moon will move away from the Earth just by 38 meters. The sun will shine just as bright. All planets and satellites will move along their usual routes. But something will have already changed. Something will be wrong with the stars observed from Earth. Namely, the North Star will no longer be polar in the original sense of the word. But the reason lies not in the star itself, but in the Earth. Our planet's rotation axis will be gradually shifting its direction in space. This process is called precession. In 1,000 years, the axis will have shifted far enough to be pointing to the star Gamma Cephei. 10,000 years into the future. The Gregorian calendar lags more than a day behind astronomical time. We sincerely hope that our civilization will still be around by this time, with some of us looking curiously up to the sky. The pole star is now Iota Cephei, due to the before-mentioned precession of the Earth's axis. And at first glance, it would seem that there is nothing fundamentally new. But there'll be a minor variation. Barnard's star will approach the solar system at a distance of 3.8 light-years. At this time, it will be our closest neighbor, closer than Alpha Centauri is now. 100,000 years. As a result of the precession, several stars will have replaced the polar star, starting with Vega. But because of such a long time passing, these events won't be so significant compared to other truly great phenomena. The sky itself will no longer look the way it used to. The proper movement of the stars will render the outlines of many constellations unrecognizable. In the middle of this period, in about 50,000 years, Niagara Falls will destroy the last 30 kilometers left to Lake Erie and will cease to exist. Our sun will be in full bloom. Nothing special will have happened to it yet, but future astronomers will record more and more signs reminding us of the impermanence of stars. One of these precursors will be the famous hypergiant star called VY Canis Major. It will use up its thermonuclear fuel and explode into a hypernova, leaving behind nothing but a nebula and a black hole. According to another hypothesis, the star could immediately collapse into a black hole without any particular special effects. But VY Canis Major is quite far away, 4,892 light-years from Earth to be exact. Its explosion won't be so spectacular when seen from Earth by the naked eye. Another famous star, Betelgeuse, will put on a much more exciting show. It is much closer to the solar system and lies 642.5 light-years away from us. It will stay for up to 100,000 years, ending up in a supernova explosion. A second sun, albeit small, will shine in the sky. The luminosity of the dying Betelgeuse will be comparable to the full moon at night. This show could last up to several months. Nothing like this has ever been observed from Earth in the entire history of mankind. Although the VY explosions of Canis Major and Betelgeuse are absolutely grandiose events, they will go almost unnoticed for the universe at large. Indeed, the observable universe will still be teeming with life. At least 2 trillion galaxies, each having hundreds of billions of stars. An era of stars will be in full swing. The era of stars. This is what astrophysicists call the era of active star formation in the universe. This period is when the universe can be considered fully alive. It is during this period that we were fortunate enough to live. The era of stars will last for billions, tens, and even hundreds of billions of years. A lot of epic events will take place over this period. In the next 500,000 years, there's a high risk of a 1-kilometer large asteroid hitting the Earth. This will put an end to our civilization if we don't move to another planet, at least to Mars. But the fate of the red planet will be even worse. In 40 million years, its own natural satellite Phobos will collide with its home planet. Keep in mind that its average radius is 11 kilometers, and such a blow will render the survival of the hypothetical biosphere of the planet impossible. As we get further and further into the future, the solar system will change even more dramatically. Let's see what happens. 500 million years. Earth will become unlivable for animals and plants due to the sun's increased luminosity and major temperature rise on the planet. After another 100 million years, tidal deceleration will move the moon away from the Earth so much that a total solar eclipse will become impossible. At the same time, annular eclipses will continue to be observed. 1.1 billion years. seawater will completely disappear on Earth, and the average global surface temperature will reach 320 Kelvin. In 3.5 billion years, our home planet will resemble today's Venus, a hot, hostile world to all living things. 4.5 billion years. By this time, the Milky Way and the Andromeda Galaxy will finally collide. The two galaxies will merge into one as a result of the collision. This may not have any bearing on our solar system in any way, given the giant distances between the stars. 5.4 billion years. The Sun will start to turn into a red giant. This process will continue for 2 billion years. Our star will grow to unprecedented sizes, engulfing Mercury and Venus one by one. The Earth has a chance to stay, but it will only be a ghost of our planet as we know it. But at the same time, another world, namely Saturn's satellite Titan, can suddenly become livable. The energy of the huge sun will be enough to create comfortable conditions for life on Titan. 7.6 billion years. After the sun passes the red giant phase, thermal pulsations will rip off its outer shell, which in turn will form a planetary nebula. A white dwarf formed from the core of the sun will remain in its center. It will be very hot and dense, but only about the size of the Earth. Initially, the surface of this white dwarf will be 120,000 Kelvin, which is 20 times hotter than is currently on the sun and 3,500 times brighter. For many millions and billions of years, it will only cool down and dwindle. Similar processes at this time will be taking place in other star systems resembling ours. But the beginning of the universe's extinction as a whole is still pretty far away. Stars will keep on actively forming and giving life to new worlds. But something completely unimaginable, both in terms of scale and uniqueness, may lie ahead. In 22 billion years, it might no longer make sense to wait for the last star to burn out because of absolutely everything going on due to the Big Rip. This is a hypothetical model of how the universe could come to an end, and one of the most epic ones because of its supposed lightning-fast, all-consuming, and all-pervading infernal power. The bottom line is that the universe is expanding, and it does so at an accelerated rate. And we know for sure that this is happening. But there's also another alarming issue when it comes to this. The universe is already expanding faster than the speed of light. This doesn't contradict physics, since we are not talking about moving objects in space, but about the expansion of space itself. The cosmological horizon is getting closer as the space expands. This is the line which separates us from everything we can no longer interact with. If the expansion continues at the same rate, there is a non-zero chance that this invisible edge will continue to contract until it collapses completely. Nothing will be able to interact with anything else by this point, and the universe will simply vanish into nothingness without a trace, as incredible as it may sound. But there's still little scientific data to back that up, and such a threatening scenario is only a theory. However, the expansion of the universe will play a special role indeed. In 100 billion years, this process will destroy all evidence of the Big Bang, leaving it behind the cosmological horizon. This will make cosmology itself impossible. Civilizations who will be born and become intelligent during this period won't have the slightest clue about how the universe came to be, and won't even have anywhere to look for it. At this stage, new stars will continue to emerge, but the majority will still die, either in epic fireworks like Betelgeuse, or quietly turning into white dwarfs like our Sun. And this will go on for a very long time. But not forever. Era of decay, 1 trillion years. This is the shortest time that it might take star formation in galaxies to stop due to the complete depletion of interstellar gas clouds required for new star formation. An era of degeneration or disintegration would creep in. 10 trillion years. There wouldn't be any more stars left that were born in our time. Even the longest-lived stars, low-mass red dwarfs, would have burned out, with a rare exception of those born much later than our Sun. White dwarfs and rare neutron stars will be the only ones still left. 100 trillion years. It's the maximum time until the star formation in galaxies ceases completely. Star formation won't be possible at this point. From that moment on, even dead stars, white dwarfs and neutron stars will die once and for all. Apart from them, only black holes will wander in the ominous blackness of space. And this universal cemetery, filled with the ghosts of the stars long gone, would exist for an unthinkably long time. In 1964, Russian astrophysicist Nikolai Semenovich Kardashev developed the theoretical classification of civilizations, taking into account not only our own civilization, but also those that can be found elsewhere in the universe. The Kardashev scale is a purely hypothetical scale based on our human understanding of technology and energy production. That is, the better your technology, the more energy you'll be able to consume. And the more energy you have, the better your technology will become. This shows a kind of endless interdependence. The original version of the Kardashev scale didn't cover intermediate values. However, Carl Sagan proposed to expand the scale's applicability using interpolation and extrapolation to change it from rank scale to an absolute one. So, let's begin our journey. Type 0 civilization is the human civilization. Level 0 is where we are at. At this level, not all the planet's energy is used. But why hasn't our human civilization reached even the first level? Today, we use a variety of natural resources to generate energy, such as wind, water, solar, and nuclear energy. However, according to the astronomer Carl Sagan's calculations, our current level of knowledge and research is barely enough to call ourselves a 0.7 level civilization, with an energy consumption of about 4 times 10 to the 12th power watts. This value comes from the fact that humanity uses about 0.16% of the total energy resources of the planet. It is so small that if a regular glass of water represented the Earth's entire energy volume, we wouldn't have even sipped a quarter of a teaspoon from there. We'll need another 100 to 200 years to be called Type 1 civilization, if the GDP of many countries will grow by 1 to 2% per year. Type 1 civilization is a planetary one. Imagine being able to control the weather from tsunamis to earthquakes. We would be able to get energy from everything that surrounds us, even from continental plate movement and regular rain. The electricity problem would disappear. We would stop depleting the Earth's natural resources and become independent from oil. Perhaps then, fundamentally different professions would emerge, such as a continental plate constructor or weather engineer. Type 1 civilization is able to use all the energy coming from the star to its planet, 10 to the 16th power watts to be precise. For Earth, that is about 150 petawatts. 1 is followed by 17 zeros. This greatly exceeds what humans can use. In 2019, the world's average energy consumption was estimated to be 20.0 terawatts, or 0.73 on the interpolated Kardashev-Sagan scale. If we really wanted to use all solar energy received by Earth using current methods, we would have to cover the entire surface of the planet with solar collectors. This wouldn't only be very expensive, but also impractical, because humans would be forced to live somewhere underground. However, we can get an equivalent amount of energy in another way. For example, by building large solar power plants in space, or by constructing and extensively using thermonuclear power plants. To become a Type 1 civilization, we'll have to convert about 280 kilograms of hydrogen into helium per second and collect the energy released. This will amount to just under 9 billion kilograms of hydrogen per year. Although this sounds like a lot, it's 10,000 times less than in a cubic kilometer of seawater. And since the Earth's oceans contain quite a lot of cubic kilometers of water, we could also produce energy for at least 1 billion years as a civilization of the first type. Type 2 civilization is a stellar one. Type 2 civilization is capable of using any energy emitted by the central star, in our case the Sun, which is 10 to the 26th power watts, and exceeds our current energy consumption rate by 1 billion times. If we could utilize universal solar energy, we'd be a Type 2 civilization, according to the Kardashev scale. The most famous method for achieving this goal is the so-called Dyson sphere. The concept of this method belongs to astronomer Freeman Dyson and was developed back in the 1960s. To put very simply, Dyson proposed constructing a system around a star that would collect all the energy and make it available. If you built a spherical capsule around the Sun with a diameter equal to the diameter of the Earth's orbit, you would receive about the same amount of energy that we receive now on Earth. However, in general, we could use all 10 to the 26th power watts. We'd also have much more room inside this Dyson sphere. Its surface area is 550 times that of Earth. It sounds good in theory, but comes with a few problems. We wouldn't feel the gravitational pull inside a spherical shell. We'd have to somehow make the giant spherical structure rotate in order to create artificial gravity. We would also need to change and adjust the position of this construction relative to the Sun to prevent it from shifting sideways over time. As if this wasn't enough, the material of the sphere must be unimaginably strong in order to withstand the operational forces. And then there might not even be enough material. We'd have to collect it from all over the solar system, disassemble entire planets such as Mars, Mercury, or Venus to obtain massive cores from the interior of gas planets. Even if this was possible, we could only build a 15-centimeter thick spherical structure. It would become an easy target for comets, asteroids, and other things that would collide with the sphere from the outside. But of course, there might be some alternatives. Instead of a Dyson sphere, we could build a Dyson swarm. In other words, many small structures orbiting the Sun and collecting as much energy as possible. Then we could either live right there or somehow transmit the energy to Earth. One can also build a ring instead of a full sphere. Or we could look for other methods to obtain the amount of energy required for the second type. Type 2 methods can be used on different planets and thus increase the yield. We could probably just steal some hydrogen straight from the star and use it to power fusion power plants. Those civilizations that have already reached the first level are advanced enough to produce antimatter in large quantities and can use it for energy. We'll need another 1,000 to 2,000 years before we can call ourselves a Type 2 civilization. Having reached the second type, civilization will populate the sphere in order to completely control it, virtually living in the Sun, which in my opinion sounds pretty cool. But even if you've used up all the star's energy, you can go one step further. After all, the sky is full of stars, so why leave all this energy unused? Therefore, Kardashev created the third level. A Type 3 civilization is a galactic one. In our case, reaching this level means being able to use any energy in the Milky Way galaxy. The power consumption of such civilizations is estimated to be approximately 10 to the 36th power watts, which is the energy given by 10 billion stars. Our galaxy has several hundred billion stars, and therefore several hundred billion times more energy to collect. Of course, one could simply surround the stars with the appropriate Dyson structures. As a result, the entire galaxy would be composed of Dyson sphere systems. Energy storage methods would move to a fundamentally new level. But who knows what else such civilizations might come up with? Perhaps they can somehow use the energy released near the supermassive black hole in the center of our Milky Way. Or maybe they can use the energy generated by supernova explosions. One can only speculate. Traveling between the Dyson spheres would become commonplace. We would be able to populate every corner of the Milky Way. Our life would virtually strive for infinity. Our navigation systems would have maps of the whole galaxy, and we would visit other star systems on vacation. In theory, we can look for such super civilizations. The star hidden behind the Dyson sphere is no longer visible, but the sphere itself heats up and throws heat back into space. Instead of a star, we could see a sphere dimly glowing in heat, i.e. infrared light, which is strikingly different from the natural infrared radiation emitted by stars or planets. If each of the stars in the galaxy, or at least most of them, were altered in this way, we would notice it by the changes in the light coming to us from a particular galaxy. Humanity will have to exist for another 100,000 years and constantly evolve technologically to reach this level of progress. Visiting such a civilization would be something from the world of sci-fi. A civilization of this type would be able to colonize star systems and build a large number of Dyson spheres while getting energy from the stars. The galaxy will become a sandbox for a Type 3 civilization, which is quite difficult to imagine. Thus, the main types differ from each other by a factor of 10 billion, i.e., the energy consumption of Type 3 civilizations is 10 billion times higher than that of Type 2 civilizations. In 2007, researchers discovered something strange when analyzing archival data from the Australian Parkes telescope. It was a millisecond burst of high-intensity radio emission. Down frequency across time in milliseconds. The burst signal is represented by a dark bar. At low frequencies, the signal arrives later due to the dispersion of radio waves in the intergalactic medium. The inset shows the signal's time profile at a fixed frequency. Scientists realized right away that this was at least something unusual. But only very few people knew the whole significance of this fantastic phenomenon. A new term was coined to refer to it, called fast radio bursts. From the distinctive difference between the rate of the signal's arrival at higher and lower frequencies, scientists have inferred that the source is very far away, billions of light years from Earth. This means that the signal source is extremely powerful to overcome all cosmic matter. 10 raised to the power of 43 ergs per second. This is 3 billion times more luminous than the Sun. I'll repeat this one more time. 3 billion times more luminosities than the Sun in just 1 millisecond. And all this energy is being conveyed in the radio band. This sounds like pure science fiction. This was how a long scientific search began. Astronomers rushed to find similar events. Fortunately, they didn't keep scientists waiting. In just a few years, radio astronomers discovered bursts with similar properties, and it became clear that this was a whole type of new astronomical phenomena. However, the discovery of more and more facts did not at all provide the answer to the main questions. What gives rise to these mysterious outbursts? And more importantly, how? For the longest time, the localization accuracy of fast radio bursts in the sky was very low, about a few square degrees. Trying to identify a source in such an area without a single idea of what it can be is like looking for a needle in a haystack. However, what really grabbed scientists' attention was the uniqueness and improbability of these phenomena that deemed such events highly unlikely. Lee Billings gave a vivid analogy in Scientific American. The average FRB radio signal on Earth is 1,000 times weaker than a signal of a typical mobile phone on the moon. But if we take into account that the source is actually billions of light years away, it turns out that its power must be absolutely out of this world. The thing is that neither at the time the first FRB was discovered in 2007, nor for many subsequent years, it wasn't possible to comprehend what unimaginable forces could generate such a surge. The closest thing that came to mind was gamma-ray bursts, whose nature was a subject of many fervent debates in the scientific community for 3 decades. In the end, their sources were discovered and turned out to be mostly supernova explosions. However, with these radio bursts, everything was much more complicated and incomprehensible because before the FRB was discovered, no one could theoretically fathom the existence of something that could squeeze all the energy of the sun's luminosity into the radio range, multiply it by 10 billion, and shoot all of it with unimaginable power in just a millisecond. Up until now, such phenomenon didn't seem plausible to anyone. Even the most powerful hypernova releases a chunk of its energy in the gamma range. Undoubtedly, the radio range accounts for an insignificant share of this emission. Scientists were confused, and it took years before this whole thing began to clear up. What made it difficult to identify this phenomenon was that for a long time, FRBs were only isolated. With yearly improvements in detection methods, astronomers were able to record dozens of fast radio bursts. Statistical analysis showed that the number of fast radio bursts across the entire sky should be on the order of several thousand per day. Finally, one fast radio burst was found to recur regularly. FRB 180916 pulses every 16.35 days. Then, there were found some consistency in the coordinates of other previously noted bursts. They were accompanied by some oddities too. For example, some sources pulsed irregularly, but still in multiples of a certain number, and that was at least something to go on. Let's just keep in mind that when we casually say source, we're just reiterating what researchers said. In fact, scientists had no idea what they were at that time. Identifying regularities in some FRBs was good news in the scientific community, but it did not come close to uncovering their nature. Still, it was difficult to make progress with the research without determining the exact location of the source. Desperate times called for desperate measures, and astronomers resorted to interferometry, which is the most accurate astrometry instrument. The tool is even more accurate in the radio range, since the detector's base can be the size of the Earth, and in experimental projects like ReYOUniverse, even tens of times larger. But even with instruments like interferometers, catching radio bursts was very challenging due to the narrow field of view. But finally, it happened. On January 4th, 2017, a group of radio astronomers reported in the Nature journal the first astrometric localization of one of the short pulse sources, namely FRB 121102, the legendary VLA, and the even more legendary 305-meter radio telescope in Arecibo became the heroes of the event. Unfortunately, the latter one is now gone for good. Astronomers finally had something to go on. This particular FRB 121102 source was regular. In 83 hours, it was observed by the VLA in the 2.5 to 3.5 GHz frequency band within 6 months. 9 short, bright bursts with the same dispersion value were recorded. The localization accuracy was on the order of 0.1 arcseconds, which can be compared to the accuracy of the best optical observations. It turned out that near the source of the recurrent FRBs, there is a weak radio source with continuous non-thermal spectrum. According to archived observation data of 2014, a faint object of about 25th magnitude was consistently present at the source site. This was revealed using the Keck Observatory's 10-meter optical telescope and the Gemini telescope. Additional super-long baseline radio interferometric observations done with millisecond precision from the European Radio Telescope Network confirmed the VLA results and showed that the constant source and the FRB source were separated by less than 0.12 milliseconds. This confirms that they might be physically connected. Spectroscopy of an optical source at the North Gemini Telescope in Hawaii showed that optical radiation comes from a dwarf galaxy lying at a distance of about 1 gigaparsec, which is approximately 3 billion light-years, weighing 40 to 70 million solar masses, and having a high specific star formation rate. This was followed by further improvements in localization methods, and scientists found more and more precise locations of FRB sources. Most turned out to be extragalactic, but in April 2020, the Canadian CHIME Radio Telescope discovered the first FRB in our home galaxy, the Milky Way. In June 2021, astronomers reported more than 500 detected FRBs in space. Finally, with the launch of the 500-meter Fast Radio Telescope, also known as Tianyan, the Eye of Heaven, the number of fast radio burst detections went up to thousands. Scientists have finally got hold of large volumes of data that can potentially explain the nature of these bursts. Currently, hundreds of articles have been written about the nature of fast radio bursts, where scientists have put forward several dozen hypotheses. From completely plausible ones associated with explosive processes near neutron stars to exotic ones, attributing them to the last breath of evaporating black holes. The proponents of the artificial nature of these phenomena are also quite hopeful. They talk about gigantic radars of extraterrestrial civilizations, acceleration drivers of intergalactic ships, space sails, and so on. As new data becomes available, some of the theories become discarded with relief or regret. Scientists are now taking a closer look at some of them. The search continues, and thanks to such tools as FAST, for the first time in many years, we have a chance in this decade to unravel the mystery of fast radio bursts coming from deep space. In 1970, American scientists Raymond Davis and John Bacall studied the inner structure of the Sun. A special device was installed in a deep underground mine. It made it possible to register the effects of neutrinos, exclusive particles produced in the Sun's core. The particles themselves are very difficult to detect, but traces of their flight are detectable through some indirect signs. Right after launching the device, scientists faced a strange and frightening problem. The detected neutrino flux was exactly 3 times weaker than expected. First, Davis and Bacall checked the calculations and how the experiments were run. No error was found. Moreover, other specialists couldn't find any errors either. The neutrino flux from the solar core was indeed 3 times weaker than it should have been. There was no doubt about that. Astronomers were horrified because at first, this meant only one thing for them. For some unclear reason, the solar core's activity was 3 times weaker than usual. No one could determine when this drop in activity happened. If the core's activity decreased long ago, then the Sun could go out at any moment, even tomorrow. or this very second. Unlike astronomers, nuclear physicists just shrugged their shoulders and said that neutrinos were largely understudied particles. Perhaps we were misguided about some of their properties. Fortunately, they were right. Scientists survived the end of the world. But for how long? To find out our native star's future, we can use a time machine, but not necessarily to go forward. The way the star dies, be it colorful fireworks or a slow and sad demise, depends on how the star was born and what were its initial materials. That's some really good food for thought for those who believe in fate. In this video, you'll find out how much the sun is worth, how round and large it is, when it will go out, what the sun's temperature is, why we see the light from 170,000 years ago, and finally, when the sky will turn pitch dark and completely starless. It all started with a cloud of dust and gas. The ancient gas and dust nebula was in relative equilibrium until something happened. There is a version that an ancient massive star exploded in a supernova somewhere nearby. The resulting shockwave turned out to be strong enough to trigger fluctuations in the gas-dust nebula, which created points of attraction. This theory is supported by the fact that when studying meteorites, scientists discovered quite a few elements that could have been formed only during a supernova explosion. The points of attraction that arose grew like a snowball. Over time, the size of this giant ball became grandiose, amounting to a quintillion tons. Such a gigantic mass was compressed under the effect of gravitational forces, while simultaneously being heated by internal pressure. This went on until thermonuclear reactions started. In the central part, the sun's temperature rose up to 15 million, and the pressure reached hundreds of billions of atmospheres. Thermonuclear reactions precipitated until, at a certain point, the pressure from the thermonuclear furnace was balanced by its own gravity. The star as we know it has appeared. Still young and a little different, but still much like the sun we know. Despite being very familiar, the sun will turn out to be a very curious star indeed if you dig a little deeper. First, it is very large. Its diameter is 1,392,700 kilometers, while that of the Earth is 12,742 kilometers. That means 109 Earth-sized planets will fit in the diameter of the sun. Second, it is super heavy, almost 2 by 10 to the 30th power kilogram. This is 332,946 times the mass of the Earth. If this figure doesn't tell you much, here's another one to keep things in perspective. The mass of the sun is 99.86% of the entire solar system taken together, with Earth, Jupiter, all other planets and their satellites, all asteroids and comets combined. Statistically speaking, there is hardly anything in the solar system apart from the sun. Third, it is very hot. The temperature reaches 5,505 Celsius on the sun's surface. That's a lot, but still not too impressive. However, its core is much hotter, reaching up to a whopping 15 million degrees. It is there that thermonuclear reactions take place, and gamma radiation is born, which is then converted into visible light. Interestingly enough, the photons of the generated gamma radiation wander inside the sun along a complex trajectory for a very long time, on average about 170,000 Earth years. When transferring heat from the core to the photosphere, each gamma ray in the sun's core is converted into several million photons of visible light before leaving for space. And only from that moment on, the light needs more than 8 minutes to reach the Earth. That means we are still warmed by the light that was born when Homo sapiens had not even gone beyond Africa. And by the way, The sunlight is not yellow. Our star is called a yellow dwarf, but this is just a term. It seems yellow only to us. Its light acquires a yellow tint near the surface of our planet due to the short wavelength part of the spectrum being scattered and absorbed by the Earth's atmosphere. However, the sun appears white in space. Also, the sun is very round. It would seem what could be more obvious, but in fact, we know very well that nature does not particularly favor regular shapes. The Earth is round too, but the sun is much rounder. The shape of the Earth is a flattened spheroid instead of a true sphere with an equilateral bulge of 42.72 kilometers. For the sun, the difference between the hypothetical width and height doesn't exceed 10 kilometers. It may sound funny, but the sun is also very expensive. Literally. In a 2014 study, a team led by astrophysicist Nicholas Groves of the University of Liège found that there are 8 gold atoms per billion hydrogen atoms in the sun. This doesn't seem like a big deal, but in fact, this amounts to 2.34 quintillion tons on a short scale. It's equivalent to the famous dwarf planet Ceres, almost 1,000 kilometers in diameter, being made of pure gold. This is the sun as we know it. But it's constantly changing. The sun is gradually warming up because the helium atoms in the core are denser than the hydrogen atoms from which they were fused. This increases the gravitational pressure on the core, which is counteracted by the gradual increase in the fusion rate. In the 4.5 billion years of the sun's existence, it has become 30% brighter and will continue to brighten by 1% every 100 million years. In the sun's lifetime, about half of all the hydrogen available there burned down to its center. However, the sun's form will remain virtually unchanged from what we know in the following 5 billion years. After the sun core depletes its hydrogen supply, the sun will grow in size and become a red giant. This will have a profound effect on the Earth. The temperature will rise, and the oceans will boil away, wiping out life as we know it. Eventually, the sun will swell, engulfing Mercury, then Venus, and finally, the Earth. However, scientists aren't completely unanimous here. Perhaps our planet will be able to avoid absorption, but this changes little for humanity. At that time, earthly conditions would very much resemble inferno. Then, having completely spent the thermonuclear fuel, the sun will no longer be able to hold its own outer layers. The red giant will begin to shed matter layer by layer, gradually becoming smaller. At the final life stage, the sun will become a white dwarf, delighting extraterrestrial astronomers of the future with a new planetary nebula. Its shape may turn out to be very bizarre due to the influence of planets. But that's not the end. The white dwarf will continue to emit light, which means it will cool down. It will take the sun 1 quadrillion years to cool down completely. That's 1 million billion years. This will literally take ages. In that epoch, there will be no free hydrogen in the universe left for new stars to be born. All the old ones will go out or explode by that time. The sky will turn completely black. Can you imagine a pitch-dark, completely starless sky? And our sun will no longer be the sun we know it today, but a black dwarf, a cold ball of carbon. Is this the end? Not really. Further scenarios are still only obscure hypotheses. True black dwarfs haven't appeared yet because they take an incredibly long time to form. The ideas on the future fate of black dwarfs differ radically, ranging from slow evaporation to becoming a supernova. Sounds incredible? Not really. After such a huge span of time, our universe will be completely different, and there are serious reasons to believe that it will be something completely unexpected. The cloud got its own name, Arzia Mons Elongated Cloud, or AMEC for short. What's strange is that such an amazing object as a huge cloud wasn't noticed until 2018. But when it was spotted, the Mars Express visual monitoring camera tracked the evolution of this cloud hour by hour, from the time it emerged to when it vanished. In addition, it turned out that this cloud was observed by space stations before. Scientists have studied archival images and found the cloud in pictures taken by different satellites orbiting Mars. It was even captured by the heroic Viking 2 in 1975, the one whose lander transmitted the first color images of the red planet. Of course, there are other clouds on Mars, but they aren't as huge as this one. By and large, Mars is a desert planet. It has by 2 orders less water in its atmosphere than in the driest regions on Earth. Compared to Mars, the Sahara Desert looks like the tropics in the monsoon season. Mars's atmosphere contains a total of 1.3 cubic kilometers of ice. This figure is 100 million times higher here on Earth. But nonetheless, there are clouds on Mars formed from ice particles. Martian clouds, unlike ours, can form not only from water, but also condensed CO2. After all, it can be very cold up there, up to minus 140 degrees. This is what Martian clouds look like from orbit. Compare this paleness with our beautiful blue and white Earth. And this is how Martian clouds look from the planet's surface, as captured by Curiosity rover. Earth clouds form when water vapor condenses on dust particles, grains of sand, and salt crystals. However, this mechanism can't occur in Mars's low-density atmosphere tens of kilometers high. Scientists from Colorado State University associate the clouds on Mars with dust entering its atmosphere from space. Every day, 2 or 3 tons of small meteors fall into Mars's atmosphere and are scattered in its upper layers. Computer models have shown that a significant portion of these particles can stay suspended high in the atmosphere and condense moisture. Of course, they don't reach the density we are used to, but the formation significantly impacts the state of the Martian atmosphere, causing local temperature fluctuations within the 10 degrees Celsius range. But the mysteries of the Martian cloud don't end there. First of all, why don't such orographic clouds form around the other 3 large Martian volcanoes? For example, the truly impressive 26-kilometer-high Olympus, which coincidentally is the highest volcano in the solar system, is just a stone's throw from AMEC. One theory suggests that only the area around Arzia Mons provides enough humid air that can turn into ice and snow. Another question is, how does so much moisture accumulate in one area on lifeless Mars? Is it possible that there is an underground reservoir that starts to evaporate intensively in the Martian spring and creates the Arzia Mons Elongated Cloud? And anywhere there is water, there is a chance to find life. We are looking for it hundreds of light years away on planets with Earth-like conditions near other stars. Yet, extraterrestrial life can be literally just around the corner, some 70 million kilometers away. You may ask why only Mars Express observes Arzia Mons Elongated Cloud. Indeed, there are currently 6 spacecraft orbiting Mars. 3 of them are American: Mars Odyssey, Mars Reconnaissance Orbiter, and Maven. The other 3 are the European Mars Express, the Indian Mangalyaan 1, and the Russian-European TGO. In early 2021, 3 additional spacecraft were added at once: the Hope of the United Arab Emirates, the Chinese Tianwen-1, and the American Perseverance. But the fact is, only Mars Express is in the right place and at the right time. Other satellites don't fly over the area at all, or don't catch it in time. Fortunately, Mars Express has a highly elliptical orbit and is equipped with a wide-angle VMC, allowing it to take images of this surface area early in the morning. Scientists were super lucky to put this visual monitoring camera on Martian Express. After all, initially, its sole purpose was to observe the landing unit's descent. With only 640 by 480 pixel resolution, it certainly doesn't provide the precision needed for research. But even with such low resolution and a bit of luck, one can still make some great discoveries. So what is this cloud anyway? It wasn't until 3 years after its discovery that scientists understood the cloud's nature. The findings have been presented in the study by Jorge Hernandez Bernal's team from the University of the Basque Country in Bilbao. They assume that this isn't a cloud at all in the usual sense of the word, meaning it's not ice condensed on meteorite dust, but rather an accumulation of ice and dust particles raised by an atmospheric current ascending along the mountainside. Such clouds also exist on Earth, and they form near mountains too. They are called orographic, which means clouds painted by the mountain in Greek. But they can't be compared to AMEC with its 1,800-kilometer long and 150-kilometer wide trail. So how did this giant Martian orographic cloud form? Naturally, the cloud was generated by Arzia Mons volcano that makes it harder for Martian air to pass. Even though the Martian clouds are super thin and the pressure on the planet's surface is 170 times weaker than here on Earth. But the tremendous speed of 600 kilometers per hour more than makes up for such a low density. This is twice as fast as Formula One race cars. At dawn, denser air layers cut into the 20-kilometer high volcano and become sharply compacted. Their moisture condenses on dust particles, turning them into tiny specks of ice. This bulk of ice, air, and dust begins to rise from the foot of the volcano along the western slope to where the temperature is lower until it reaches the top. But even then, the whole stream goes up another 25 kilometers, and only at an altitude of 45 kilometers does it expand and quickly stretch in the wind. Also, the cloud head separates from the top of the volcano. Then, AMEC itself is moved by the high-altitude wind to the west, where it dissipates, evaporating in the morning sunlight. The Mars Express camera captured all these stages of AMEC evolution. And here is this cloud in all its glory. You can clearly see its head, which has separated from the volcano. Behind the head, as expected, goes the neck, followed by the tail, where the ice stream starts to expand. And here is a computer model of how this Martian phenomenon spreads. AMEC forms every Martian year during the planet's southern summer solstice, when Mars's southern hemisphere is exposed to sunlight. It starts on October 16th. The cloud forms early in the morning, builds up over the next few hours, and then quickly dissipates. The entire cycle, from the time the cloud emerges to when it evaporates, takes about 11 hours, and so on for about 80 days. Webb's predecessor, the Hubble telescope, was launched into orbit back in 1990. Many of the viewers were not even born then. No one imagined back then that this tool would work for as long as 30 years and even more. But all predictions aside, it was obvious that in the future, it would need a worthy, more perfect substitute. The idea for a new space telescope project came about in 1996. Initially, the launch was scheduled for 2007, and the initial project budget was about $0.5 billion. But the design and construction of the telescope turned into a whole epic worthy of a full-length drama movie. The first segment of the mirror was installed on the telescope as late as the end of 2015, and the main mirror was completely assembled only in February 2016. A whole generation has grown in the course of this 25-year-long project, and the telescope's launch was postponed 17 times. Over the years, the project's budget has grown to almost $10 billion. What is this incredibly expensive tool? James Webb is a quite large structure compared to other modern space telescopes. Its most impressive part is the sun shield, which is 20 meters long and 7 meters wide. This is equivalent to a tennis court. By comparison, the Hubble telescope is 13.3 meters long and 4.3 meters in diameter without solar panels. The new telescope's mirror looks no less impressive. Its diameter is 6.5 meters. This is almost 3 times larger than that of Hubble, which has a mirror with a diameter of 2.4 meters. In terms of weight, Webb also significantly outperforms Hubble, but the other way around. The Webb telescope weighs 6.2 tons. That's a lot, but the much smaller Hubble weighs a whopping 11 tons. The challenge for the engineers was to keep the telescope as light as possible so that it could be delivered to its destination. The Webb telescope is equipped with a whole set of devices for space exploration. The basic tools are near-infrared camera, device for operating the middle infrared range, near-infrared spectrograph, high-precision aiming sensor, an imaging device in the near-infrared range, and a slitless spectrograph. The very features of the telescope are intriguing. The way it's designed and the sheer amount of work that has been put into this is breathtaking and shows the power of human genius. If the purpose of the mirror is more or less clear to everyone, but some might wonder as to the purpose of its largest part. Its role is to protect the telescope from sun rays. A special polymer film was used to manufacture the shield, covered with a thin layer of aluminum on one side and metallic silicon on the other. Vacuum will fill the space between the layers of the heat shield. These interlayers make it difficult to transfer heat to the telescope's core. Such multi-layer protection is necessary to maintain an extremely low temperature of minus 220 degrees Celsius in ultra-sensitive matrices. Without this, the telescope will be blinded by the infrared glow reflected off its own details, rendering the light of distant objects almost unseeable. The mirror consists of 18 hexagonal beryllium segments. This beautiful yellow color of each segment comes from nothing more than the purest gold. Gold plating ensures the best reflection of light in the infrared range. It will effectively reflect infrared radiation with a wavelength of 0.6 to 28.5 micrometers. With only 100 nanometers, its gold layer is unusually thin, and the total weight of the coating is only 48.25 grams. A secondary convex mirror is installed on a special mount in front of a set of 18 segments of the main mirror. Radiation reflected from the main one will focus on it. In turn, this most valuable image will be converted into digital data and analyzed by onboard scientific equipment. The James Webb Telescope is a triumph of technological thought, to say the least. It is the most difficult and most expensive project in the history of astronomy, with a very long, difficult, and very dramatic past. And now, finally, the project is one step away from its peak. All of us, with bated breath, will follow the launch and flight of the device to its destination. After the launch, the device will fly into a halo orbit at the L2 Lagrange point of the Sun-Earth system. The Lagrange point is a special place where the gravity of two neighboring bodies balance each other out. In 1772, mathematician Joseph-Louis Lagrange calculated in his study the problem of three bodies, that the Earth's gravitational field should neutralize the gravitational pull of the largest object in the solar system, the Sun, in 5 regions of space. In fact, these 5 areas are places in our solar system where gravity virtually doesn't work due to the equal force of attraction from several cosmic bodies. Webb will head to one of these points, namely L2. This means that, unlike Hubble, the new telescope won't orbit the Earth or even hover in geostationary orbit. Instead, Webb will orbit the Sun in sync with our planets. The distance from the telescope to Earth will reach 1.5 million kilometers. Such a long distance means there won't be any way to upgrade or renovate it, as was possible with Hubble. Therefore, the entire concept of James Webb is about exceptional, top-notch reliability. The super-sensitive Webb mirror will target objects in our solar system as well as the most distant regions of the visible universe. This golden eye will unravel new secrets of space. Webb will study the watery worlds of the solar system, Jupiter's moon Europa, and Saturn's moon Enceladus. The near-infrared NearCam camera will be able to obtain high-resolution images of Europa to study its surface and find regions with geysers and high geological activity. The composition of the recorded geysers will be analyzed using NIRSPEC and MIRI instruments, a device operating in the mid-IR range. The data obtained from these studies will also be used in exploring Europa with the Europa Clipper probe. As for Enceladus, it won't be possible to obtain high-resolution images, but the telescope's capabilities will be enough to analyze the molecular composition of its geysers. It's also planned to observe small bodies of the solar system, such as Ceres, Pallas, the asteroid Ryugu, trans-Neptunian objects, centaurs, and several comets. But Webb's main goal lies outside our solar system. It has to reveal the light of the first stars and galaxies that appeared after the Big Bang. The fact is that the equipment installed on the new telescope will allow us to see 800 million light-years farther than Hubble, which is a record in its time. This means that we'll be able to see the way the universe was just 100 million years after the Big Bang. The results can dramatically change the way we see the universe. NASA also officially announced that the list of priority objects for the study will include 17 of the 20 protoplanetary disks closest to our system. Their images were obtained in 2018 by the ALMA Radio Telescope Complex in the Atacama Desert in Chile. Webb will measure the spectra of protoplanetary disks to give scientists an idea of their chemical composition. This way, we can establish the presence of water in a potentially habitable zone, where other conditions are suitable for the emergence of life. Finally, the equipment installed on the James Webb Telescope will allow us to identify exoplanets lying 12 astronomical units away from their stars at a distance of up to 15 light-years from us. Overall, it will be possible to observe the planets located near dozens of stars neighboring our Sun. Moreover, Webb will be able to see not only the planets themselves, but their satellites as well. The telescope is expected to last 5 to 10 years. This is more than enough for many amazing discoveries. Humanity can expect a revolution in the study of exoplanets, and perhaps not even one.